Hello everyone and welcome back. In a previous video, I showed the basics of how to use Flask to set up an API endpoint. And the API endpoint that I was setting up was a predict route. So the idea of the predict route was the client would pass in attribute values for four attributes: level, language, tweets, and PhD. We would parse out those attribute values from the query string, and then we would use them to make a prediction using a decision tree. We would then take that prediction from the decision tree and return it as a JSON response back to the client. I did steps 1 and 3, but I skipped 2. Now I want to come back and show you how to do 2. So here's the simple data that we're working with. We've got a decision tree that, given values for these 4 attributes, produces a prediction of true or false whether a candidate interviewed well or not. How the decision tree was constructed, though not relevant for the video, how it was constructed was using entropy-based attribute selection for a top-down induction of decision tree algorithm. The solution for this entropy-based top-down induction of decision tree algorithm is the tree I just showed you graphically, and represented as a nested list in Python is right here. Once again, how the tree was constructed is not relevant for the video. What is relevant for the video is the fact that you have some trained model, okay? This trained model is stored in memory via a Python object, and you want to save that Python object to be used later as part of your web app in a different Python process running on a server. So I want to show you how you can achieve this. So the first thing I'm going to do is I'm going to copy my interview tree. For you, this would be training some model and then having that Python file open where you're training the model. I'm going to create a little Python program here called interviewpickler.py. I'll explain the pickling here in a moment. I'm going to paste the interview tree, and I'm also going to copy and paste the header. Okay, so the header contains the names of these 4 attributes that are used in the tree: level, language, tweets, and PhD. Actually, the language attribute is not important and not used in the tree, but we'll still include it here to be complete. All right, so now let's take some notes at the top here. So the goal is to pickle, or I'll put in parentheses here, save to a file. The goal is to pickle or save to a file the header and interview tree so that file can be used later to create Python objects from the file to be used in another Python program or Python process. Okay, so the key part here is you've got a Python program that trains a model. You want to use that model later, right? Perhaps 5 minutes later, an hour later, a week later, whatever. You want to use it later, not in this same currently running Python program. So how do you save the state of your machine learning model that's just been trained? Well, we can save its state to a file using a Python process called Pickling. Then we can just take that file, and when we're ready to use it, like I said, 5 minutes later, an hour later, a day later, a month later, whatever, we can unpickle the file, meaning load the file back into memory as a Python object. So I'll say here, unpickling. So this is kind of the big picture. If you've heard of object serialization before, this is essentially what pickling is doing. When you serialize an object, you essentially write it to a byte stream, and then you write that byte stream to a file in binary format. Pickling's going to do the same thing. We just call it pickling because that's the name of the standard Python library for object serialization in Python. So we're going to import pickle, and we're going to pickle or save as a binary file, serialize. Okay, these are all synonyms. Our header and our interview tree. So I'm going to package these two objects into one. I'll call it the package object. It's a list of header and interview tree. Then I'm going to pickle the packaged object to a file called tree.p. And I can name this whatever I want. The .p is kind of a convention for pickled objects, but really you can name this file whatever you want. So I'm going to open a file called tree.p for writing in binary mode, okay? A pickled object, okay, is going to be a binary file, which means we're not going to be able to open this file up in VS Code and easily read the contents of it. It's machine readable, it's binary, it's not human readable, or it's not plain text. All right, then I'll do pickle.dumps, or excuse me, pickle.dump, this first one here. Write a pickled representation of an object to the open file object. Perfect. So pickle.dump, I'm going to pass in first, what is the object that I'm going to pickle? That's the package object, and then the file, out file. I'll close my out file. I will run. Let me kill my Flask app here. All right, here we go. I just ran interview pickler.py. It produced this tree.py file, which I can try to open in VS Code, but as I alluded to, it says the file is not displayed in the editor because it is either binary or uses unsupported text encoding. Do you want to open it anyway? No, I do not. Okay, so just to recap, we just pickled these two Python objects to a file called tree.p. Okay, imagine this is your awesome machine learning model that you've trained and tuned and perfected, and you're ready to deploy it. So you save its state by pickling it to a file. Now, later, you can unpickle this file essentially to inflate the state of this pickled file back into a Python object to be used at a later time. So that's what I'm going to do. I'm going to head over to my interview app.py, and I'm going to import pickle. And now, approach number 2, I want to make a prediction using the decision tree. Well, the decision tree was trained in a different Python process, but I saved its state to tree.p by pickling it. So time to fill this to-do. Let's get a prediction back from a call to a function called predict interviews well. I'm going to be passing in a list, which represents my unseen instance defined by the 4 values I extracted from the query string. All right, the steps to do this. The first step is going to be unpickle tree.p to get the header and the interview tree. Step number 2 is going to be to write an algorithm to traverse the tree based on the instance values, right? The attribute values in instance, which is just these 4 values we extract from the query string until we hit a leaf node, then return the leaf nodes class. The last step here, and it's kind of an integrated step, if anything goes wrong, we are going to return none for the prediction. So if something goes right, we'll be returning true or false. Okay, we're going to use that true or false as part of our prediction result here instead of hard coding it to true. But if something goes wrong, predict interviews well is going to return none. So we'll need to check for that when we call predict interviews well before we just blindly try and use the prediction. And a lot of things could go wrong, right? Level, for example, could be the empty string because the client forgot to provide that key value pair in the query string. What else could go wrong? We could fail to unpickle tree.p. I mean, lots of things could go wrong. This is just the kind of not so error handling error approach that we're going to take. We'll just return none if anything goes wrong. All right, so let's start with step one. Step one is to de-serialize our saved object back into a Python object. This is called unpickling. So I'm going to open tree.p for reading a binary file, so RB, read binary. This is the file mode. Okay, and then I'm going to extract the header and the interview tree from pickle.load, and I'm going to pass in file. So the pickle library's load function is going to deserialize or unpickle that binary object. It's going to return an object which I'm going to unpack into two references, header and interview tree. Just to make sure that this goes right, let's print out the header and let's print out the interview tree. And the last thing we shouldn't forget to do it, is to close the input file. All right, so let's just return none for now. That way we can test this. Okay, so I need to start my Flash server again since I killed it in order to run the pickler. So I think I have this in the first Python debug console, Python interview app.py. Okay, so I just made a request to the predict endpoint. The predict function executed because of the route. And on line 28, I called predict interviews well, which attempted to unpickle tree.p. And it looks like that was successful. Okay, so the big picture here, this is important. In another Python program that completely started and finished executing before this one, we were able to train a decision tree model. Okay, I just hard-coded the tree, but you can imagine actually running the code to train the model. Then we saved that model by pickling it to a file. And then later, we were able to unpickle that object from the file. And now we have access to the Python objects that represent our model, just like we had before, but in a different Python process. So essentially, the output of one Python process was an input to another Python process via this pickled file tree.p. All right, fantastic. All right, number two, we want to write an algorithm to traverse the tree based on the instance. Okay, that's the argument here, to predict interviews well until we hit a leaf node, then return the leaf nodes class. All right. So let's get a prediction from a function. I'm going to call this TDIDT classifier. Okay, TDIDT stands for top-down induction of decision tree. That was the algorithm that I implemented in order to build the tree in the first place. If you're using something like scikit-learn, for example, then you could just call predict in order to get a prediction. All right, what do I need to pass in? I need to pass in the interview tree, the header, and the instance. And then we will return prediction. All right, so this function here is going to be a recursive function that's going to traverse my nested list representation of the tree following the values in instance. And just to reiterate, this is because I've chosen to represent this tree using this nested list format. For your applications, you'll probably be using a library like scikit-learn, in which case you will have pickled, the scikit-learn decision tree classifier object, unpickled it, and then you can just simply call predict on it, passing in the instance. Okay, that would be a much shorter library approach to using this, but I'm going to do it by hand here. All right, so the way the tree is represented is as a nested list. Index 0 of any level of the list represents the type of information at this point in the tree. So first things first, I'm going to grab the info type from tree sub 0. Let's shorten this. I don't want to write interview tree every time. Okay, and now I'm going to see where are we at in the tree. So if the info type is attribute, okay, then I know that I'm going to have access to the name of the attribute at tree sub 1. The name of the attribute at tree sub 1. So for example, the first attribute, the root node, is a split on level. Okay, so attribute is the type at index 0. Level is the name of the attribute at index 1. Okay, the header is here if we need to, say, look up by an index value. If instead of storing the name level, I was, say, storing the index of the attribute in header. All right, now what I want to do is figure out the index of this attribute in header so that I can grab it from the instance. So I'm going to say attribute index gets header dot index of attribute. And now I can get the test value from our instance by simply indexing into instance at attribute index. Okay, so just to repeat, if we are splitting on level, okay, so attribute is level, then I'm going to figure out what is the index of level in header. Okay, so that's 0. So that's going to tell me that if I index at instance of 0, I'm going to get the value of level for this unseen instance, which there it is, level. All right, so now what I need to do is walk through for I in range 2, comma the length of the tree, and I need to grab out what is the value of this attribute by indexing at tree sub I. So for example, this first value here is this whole list for value senior, okay? So this would be 0, 1, 2. Okay, so this whole list is at index 2. If value list sub 1, okay, so this is 0, 1. Okay, so this is the value of the level attribute for this first branch or first edge off of the root node. If this value list sub I is equal to our test value, then make a recursive call, passing in value list sub 2, which is this subtree where we split on tweets. Okay, there's our recursive call. If the info type is not attribute, then the info type should be, I'll write it here, a leaf node, because we only look for a value node if we are currently looking at an attribute node. Or I shouldn't say a value node, I should say a value edge or a value link when we're currently looking at an attribute node. All right, so all I've got to do is grab the leaf label. So let's take a look at a leaf example. So let's see here, attribute level. Okay, so value mid. Okay, so value list 0, 1, 2 would be this leaf node here. Okay, so if the value, if the info type is leaf, okay, then I can get the leaf level, the leaf label at index 1. So 0, 1, so that would be true for this particular example. So tree sub 1 return leaf label. All right. I'm going to slap this whole call to TDIDT classifier in a try except block. If anything goes wrong, I'm going to return none. Okay, but if everything goes right, then I'm going to return prediction. So I'm just going to shorten this a bit here. Return what this recursive call TDIDT classifier returns. Now it's the responsibility of my predict endpoint to take a look at prediction. If prediction is not none, okay, then everything went well. And what I want to do is I want to delete this to do, move this up here. I want to return the result. I'm no longer going to hard code the class to be true. I'm instead going to pass in prediction to be the value for my prediction key, and I'm going to return 200. Okay, but if anything goes wrong, I'm going to have an else here, meaning prediction is none. That's a problem. And I'm going to simply return the string, this will be my message body, back for the client saying, hey, something went wrong making this prediction. And the status code I'm going to return is 400. So 400 is under client error responses, bad requests. The server cannot understand the request due to invalid syntax. Okay, so some of the examples I gave earlier, let's say that the query string isn't formatted correctly. So let's say, for example, instead of entering in junior, the client entered in something they made up, like retired. Well, our decision tree doesn't have retired in the domain of the level attribute. So we're going to return none and say, hey, something's probably wrong on your end. This is kind of a catch-all approach that we're doing right here, but it's a good enough approach to help us get started, at least returning an error when something goes wrong. All right, so I'm going to save this. I'm going to head back over to my Google Chrome here, and I'm going to make some predictions. All right, let's say PhD is no and tweets is yes. I get true. Let's follow our tree here, see if that makes sense. Okay, so a junior with PhD equal to no. A junior with PhD equal to no should interview well. We do get true. Now, if we change this to PhD is yes, we should get false, and we do, because now we're going down this outgoing edge from the PhD node for yes. which gives us the label false. All right. Let me head back to the code and just summarize step number 2 here. Okay, we had a to-do, which was to finish this. I was hard coding, always returning the prediction as true, but the prediction should come from the decision tree, right? So like I said, you probably are using a library where you train a model. You need to serialize or pickle that model to a file so that you can use it in another Python process later. We did that with interview pickler. I had just hard coded my tree, but you would, like I said, have some Python object from a library that represents your train classifier. You would pickle it with pickle.dump. That would write out to a file. I called mine tree.p. And then in your model, in your web app, you need to load up that model. And I did that in predict interviews well by unpickling that file to get my 2 Python objects back in a different Python process. And then I wrote this little utility function here called TDIDT classifier, which recursively traverses the tree following the values of our unseen test instance in order to get to a leaf node where we could grab the label of the leaf node, which is the prediction. We package that prediction up into a JSON result, which we send back with status code 200. If anything goes wrong, we're going to return an error and send back status code 400. So let's see how that error works. Let's say instead of, like I said, junior, I pass in retired and I press enter and I get error making prediction. So there is that 400 response code in action. You could even test this from our Python client code. Try putting in, say, retired here, and you'll see the status code you get back is the 400 that we are returning here. All right. That's the end of this video. I wanted to put it in its own video because pickling in Python is a really great topic, and it can kind of be its own standalone video. This is just a great application of it, trying to deploy a model as part of a web app. All right, the next video in this series, we are going to see how can we move this web app from running on localhost, right? 127.0.0.1. From running on localhost to running on the web. Just like I was showing in one of the first videos on how to use an API as a client, I had this very same web app here deployed as a Heroku app so that the public, the rest of the world could use it. Stay tuned, that's coming next. Thanks everyone.